It's worth highlighting that many contemporary office buildings feature extensive glass surfaces, resulting in increased electricity expenses and raising carbon emission when compared to the local climate. Architects are currently tasked with a significant mission in reducing buildings' energy consumption while maintaining a comfortable indoor environment. Dynamic facades are an important part of buildings that help save energy and keep the inside comfortable. Will be covering the location and climatic site analysis, the project design, the kinetic facade, the IEF simulation, and its results. The project is a complex building in Sheikh Zayed, Cairo, Egypt. It is surrounded by many business parks, companies, medical centers, and shopping malls. The plot is accessed from two roads, one in the north and one in the east. Therefore, any potential noise will be sourced from them. Considered a city with a temperate climate where it has a cool winter and a hot summer. As shown in the chart, that the highest temperature recorded is 42 Celsius detected in June, and the lowest temperature, which is 7 Celsius, was in January. The north and the northeast is the direction where the dominant wind and the maximum hour rate exposure. The design concept was aimed to optimizing the building orientation to maximize the ventilation and airflow. The building oriented with a majority of glazing facing north and northeast for optimal daylight and reducing the energy loads. Low emission double glazed coated windows to insulate and reduce heat gain. The 3 stories of this building will be using some passive design strategies, such as shade and shadow, to create a pressure differentiation which increase the movement of the airflow. Covering the roof to reduce the absorption of the thermal heat from the direct sun, using reflective roofing materials. The kinetic facade is inspired by the bat wings. Nothing else in the world flies the way that the bats do. Their movement is considered to be more likely to swim in the air. The bat's wings bone structure basically close to the human's arm structure. There are 5 fingers attached to the one joint to create flexibility in their flying techniques and make the difference between the flap of the birds and the swim in the air bats. The figure shows the 3 main moving axes of the structure in the shading device that have been mimicked from the bat's wing structure. There are 3 different opening ranges in the kinetic device by sliding the triangular panels in the center line of the structure from both sides to open as shown. The study will show a comparison of the energy consumption from different cases with including the following. The base case, the efficient case after changing direction to achieve the best results, applying sustainable design strategies as covering the roof since it's exposed to the direct sunlight, using isolation material, it's applying to the LEED minimum requirement, the kinetic case after implementing the kinetic facade. The building will be studied in 3 different time zones. 21st of June is being the highest mean temperature in summer, while 2nd of January is the coolest day in the winter. 21st of August is a day with uncomfortable value. 3 different simulations will be conducted for each of these dates: 5 a.m., 12 p.m., 3 p.m. The energy consumption in summer, June 21st at 3 p.m. in the base case is 67 kilowatt, while after reducing the material's UV value, changing the direction and adding the roof shade, it reduced to 58 kilowatt in efficiency, and after applying the kinetic facade, it reached to 53 kilowatt. In 21st of August at 12 p.m., the energy consumption of the base case is 56 kilowatt, while in the efficient case is reduced to 55 kilowatt. After applying the kinetic facade, it became 52 kilowatt. Next is the winter season, 2nd of January at 5 a.m. The energy consumption of the base case is 41 kilowatt, while in the efficient case is reduced to 40 kilowatt. After applying the kinetic facade, it raised to 43 kilowatt. The optimal case is to open the kinetic facade partially by opening the kinetic device in the winter month, January, February, December, and closing the kinetic device in the summer month. The total energy consumption will drop from 66 megawatt hour to 63 megawatt hour in winter only, as a total energy will be 271 megawatt per hour annually. As part of the kinetic case energy consumption, and with the help of the IES, we will obtain annual energy. In the base case, the annual energy consumption was 298 megawatt hour, whereas in the kinetic facade case, the energy consumption reduced to reach 271.8 megawatt hour. See a difference in the daylight factor of coefficient between the base case and the kinetic case. Where the daylight factor was 96 in the base case, it reduced to reach 35 in the kinetic case. The kinetic facade case has also achieved a reduction in the daylight factor percentage compared to the base case, with a daylight factor of 19 in the base case to a daylight factor of 30 in the kinetic case. The glare in the area was reduced from 197 in the base case to 50 in the kinetic case. Velocity contour in the base case between 0.12 to 0.43 meter per second, whereas the velocity contour between 0.5 and 0.25 meter per second. The temperature lies between 15 Celsius to 45 Celsius, while in the kinetic case, the temperature lies between 18 Celsius to 23 Celsius. And for the building renewable energy, we reduce energy consumption and we will sustain the building. As mentioned, the base case has an annual energy consumption of 295 megawatt hour, and with kinetic case, it's already reused to 271.6 megawatt hour. By installing 120 PV panel units on the roof of the building, which will be cover 143 megawatt hour annually.